Hello, this is Michael Tewell again, and this is part 2 of a 3-part video series on the immortality of human individuality, based on the book, Immortality, the Science of Forbidden Fruit. Now, when we ended part 1, we were discussing the limbic system, and that, as you know, from part 1 is centered in the deep middle core of the brain. The limbic system and the brain as a whole is saturated in a fluid called cerebral spinal fluid. It's a clear fluid and it saturates the entire brain as well as the spinal cord. Cerebral spinal fluid pulsates up the spinal column into the cerebral cavity inside the skull. And we want to thank Jorge Weingil for this illustration of the brain MRI through Creative Commons. You see the spinal cord here, spinal column goes down here, the cerebral spinal fluid comes up through the spinal column, saturating the spinal cord, saturating the intercranial space here. And saturating the whole brain. And as you can see, this is the limbic system that we showed before. This is an MRI of it. Cerebral spinal fluid pulsates up the spinal column into the cerebral cavity inside the skull. Now, the cerebral spinal fluid is a liquid. It's made of water and electrical conductive minerals: sodium, potassium, chloride, calcium, and magnesium. This combination of ion-carrying minerals make cerebral spinal fluid a very efficient conductor of electricity. Intracranial MRI video shows that cerebral spinal fluid flow is caused by a cardiac cycle bidirectional systolic-diastolic pulse, washing back and forth along the spinal column and inside the cranium itself. This cardiac pulsing of cerebral spinal fluid back and forth causes the sodium and potassium atoms to release ions within the cerebral spinal fluid itself in the brain. Now, we call this, it's electromagnetic and electrical fields that are being generated by the release of these ions. We call this release and this combination of electromagnetic and electrical fields the neural net. This neural net consists of coherent information existing in a quantum state, subject to the universal law of information conservation. In other words, the brain is a battery-operated biocomputer, and the information it creates and the information it stores can never be destroyed. When we face a crisis where physiological death is imminent, evolution has created the following physiological event cascade. A neural impulse signaling a crisis exists, begins within the amygdala. This signal travels from the amygdala to the hypothalamus, from the hypothalamus to the involuntary nervous system, from the involuntary nervous system to the sympathetic nervous system, and so on, all the way down to the adrenal gland. The adrenal gland releases adrenaline. If adrenaline does not resolve the crisis, eventually the adrenaline is going to be exhausted. What happens then? Well, if the adrenaline is exhausted, the pituitary gland orders the adrenal gland to release a second hormone called cortisol into the blood system. Cortisol is the last and final enhancement that our body has to ward off a crisis physiologically. The release of cortisol has a number of consequences. In other words, cortisol does a number of things. First, it causes the brain to create what are called flashbulb memories of the crisis event. The role of biophotons is supported by anecdotal reports of individuals reporting that during these crisis events, time seems to slow dramatically. The change in perception of time suggests that quantum processes are occurring within the brain during the crisis event. Quantum mechanical processes do not occur without the presence of either electrons or photons. Now, while the body produces both electrons and photons in abundance, reports of a flashbulb effect suggest that photons are being emitted rather than electrons. Second, cortisol release upregulates or turns on 3 genes, which lay dormant until the body suffers serious or possibly fatal injury: interleukin 4, interleukin 10, and interleukin 13. Third, cortisol releases copper enzymes. Copper is a perfect electrical conductor, and this release of copper enzyme would provide an efficient means of communicating to the neural net that it was time for phi alpha to begin. Therefore, it appears that phi alpha trigger is the release of cortisol. Now, if the crisis is averted, the limbic system simply discontinues cortisol release. Phi alpha is shut down without the individual being aware it ever existed. But in the event the crisis becomes fatal, however, cortisol release has already signaled the limbic system to initiate phi alpha. Time's of the essence, because once the heart stops, the brain has less than 5 minutes worth of oxygen, and all the steps leading to memory emission must occur before the brain dies. This begins steps 2 and 3 of phi alpha: memory organization and prioritization. These two stages of phi alpha are so intertwined they will be presented together. The purpose of phi alpha is to preserve only those memories which most accurately communicate our unique individuality. Now, there are 3 types of memories: ultra short-term memory, about immediate sensory perception; working memory, our day-to-day lives; and long-term memories, those memories and those neurons containing the memories which have been given enough attention to have enough energy to grow and become important to our daily and long-term lives. When an event is secured in memory, it's stored within a neurosynaptic cell. The more we think of that event, the greater the emotional weight given the event by the limbic system, the stronger the neuron's biochemical signal becomes, and the larger it grows. Therefore, long-term memories would be logically stronger and larger than the neural cells of either ultra short-term or working memories. So basically, what we're seeing here is that phi alpha will take a look at all the neurons, and it's a simple comparison. The stronger signal, the larger neuron, those are the ones that are going to be selected and subject to prioritization for phi alpha. Now, an interesting issue is the extent to which negative memories play a role in our individuality matrix of memories that we take with us from one life to the next. Negative emotions are significantly stronger than positive ones. As a result, neurons of negative memories are always stronger in signal and larger in size than neurons of positive memories. Now, this is going to have a long-term consequence. Evolution itself is to blame for this. Evolution instilled within all creatures the instinct for survival. That instinct depends entirely upon remembering how past threats were successfully overcome or avoided altogether. To accomplish this, evolution made our memories of negative events much more stronger than positive events. Now, this was done to protect us from repeating the same life-threatening mistakes. It's a survival issue with evolution. But this leads us to a paradox with regard to phi alpha. If negative emotions create the strongest memories, won't our phi alpha individuality matrix be compromised? Won't it be comprised of increasingly negative memories as we live from life to life to life? If so, does this mean that our individuality will become increasingly negative the more lives we live? Are the negative memories carried over from our past lives creating an increasingly negative memory matrix, which is unconsciously interfering with our ability to cope with the lives we're living now in the present? Well, until science takes future life study seriously, we'll continue groping in the dark on issues such as these. As to future life studies, we are no better off than Sir Isaac Newton was when his only understanding of gravity was observing the apple dropping from the tree. Once Phi Alpha prioritizes which memories are necessary to pass on our individuality, the ions containing these chosen memories are ready for the next stage of Phi Alpha. Stage 4, memory encoding. Memory encoding requires 3 components: the ions containing the prioritized memories, a place within the limbic system where the memories can be successfully encoded, and the transmission medium upon which the memories are to be encoded and emitted out of the dying body. This encoding must be an electrochemical process. It would apply the same principles as simple photography or magnetic resonance imaging. The process would have to be natural to the physiology of the brain and require little time and energy. A dying person would have little left of either. By this time, both the gray and white matter of the brain may have already become oxygen depleted. The area of encoding would need to be like a darkroom, compact and absent of all light and other electrical activity that would interfere with the encoding process. The hippocampal sulcus is a tiny, compact pocket of tissue created from the folds of the hippocampus near the amygdala. Its pocket-sized shape can readily hold and stabilize the ion-held memories in place for encoding upon the transport medium used. Second, as the hippocampal sulcus is relatively free of neural cells, it's the one location in the limbic system free of electrochemical activity which would interfere with Phi Alpha encoding. Therefore, the hippocampal sulcus is the perfect such darkroom for Phi Alpha memory encoding. It meets all the requirements we need. What is the transport medium Phi Alpha would use? What substance would most perfectly preserve the ion-held memories as they are emitted out of the dying body? The answer is clear. No pun intended. Biophotons. The brain emits biophotons as cell energy levels change. This process is a normal functioning of a healthy body. Encoding memories upon biophotons is like taking a photograph. Ion-held memories are stabilized within the hippocampal sulcus as the energy state of nearby cells decrease, releasing biophotons. These biophotons form around the ions like a pocket because that's the natural shape of the hippocampal sulcus. It's naturally made. This pocket of biophotons encapsulate the ions containing the prioritized memories. As the biophotons and ions merge, there is a sudden release of bioelectrical energy. Now this sudden release of bioelectrical energy explains anecdotal reports by emergency room physicians of sudden EEG bursts being emitted within the brain just before patients die. Researchers have confirmed the presence of biophotons in human brains both during normal healthy life and even after death. Further, the interrelationship between biophotons and the hippocampus has been well documented by independent teams of scientists. The existence of biophoton emission in the human brain is thought to be one of the more significant reasons for the rapid development of the human brain as compared to other mammals. Biophotons are much more efficient communicators of information than mere biochemical processes. Biophoton interaction with the human brain raises the mysterious spooky specter which has fascinated scientists and the general public since the early 1900s. The impact upon human existence by quantum mechanical processes. This issue has been the subject of debate between scientists for decades, but now that biophoton emissions have been observed to be a normal functioning of human existence, there can no longer be room for debate. It's proven. The human brain is an organic, quantum mechanical biomachine capable of such startling feats as quantum teleportation and quantum entanglement. Both of these capabilities may play an important role in the 5th stage of Phi Alpha, memory emission. Step 5. Memory emission. At this stage of Phi Alpha, our human subject is near death, but individuality is secured within the packet of ion-held memories contained in a transport medium of biophotons. How is it possible for the biophoton capsule or shell to be emitted out of the brain? This is also very simple. Biophotons are emitted out of the human brain all the time. Well, what are photons? Photons are elementary particles. Elementary because they cannot be broken down into smaller particles. Photons are subject to what are called what is called wave-particle duality. It means that photons share the properties of both wave energy and particle matter. For years, photons have been used to transport telecommunications information as digital, visual, and audio information through fiber cables. In 2016, the team of Raju Valvarthy and Marcel Puigvert reported the successful quantum teleportation of a telecommunications wavelength entangled photon, interacting with another photon instantly over a distance of 6.2 kilometers. This is very significant. It's proof that photons can successfully carry information, and that this process can occur instantly, seemingly in violation of the heretofore believed limit of light speed. It also causes us to recall Albert Einstein's observation that photon entanglement's apparent instantaneous information transfer created what he called, quote, spooky action at a distance, unquote. Phi alpha biophotons would be emitted from the hippocampal sulcus as discrete particles which would be measurable and receivable as any other electromagnetic wave would be. And if you want to test to see whether or not phi alpha really exists, that's how you do it. Because any electromagnetic wave can be measured. Stage 6, memory reception. Memory reception is the sixth and last stage of phi alpha. Light acts as both a particle and as a wave. As a wave, light energy can be measured. As a form of electromagnetic radiation, it can be transmitted and received like any other electromagnetic wave, like a radio. All that's needed is the proper receiving antenna aligned to the proper frequency as the transmitted wave. Logic tells us that there can only be one receiver of this type of signal. As the signal would be transmitted by a human, from a human body, the signal could only be received by another human body. Where is the antenna for reception? Where? What is the final destination of the phi alpha biophotonic wave? Well, there can only be one destination. It would have to be a living being, but one which did not yet have the life experience of its own, which would conflict with or block the memories being transmitted. The answer is as basic as it may appear weird to you. The destination of the phi alpha wave must be one place: the spinal cord of a fetus, a human fetus. Sounds crazy, doesn't it? But look at the spinal cord. Doesn't it look like the old-time wire antenna for old AM, FM radios? The ones spread out like this, and you could wrap it anywhere around a room for your radio or your sound system. Think about the human nervous system itself, the system of nerve fibers extending out from the spinal column like a web antenna. It's clear we absorb more electromagnetic waves than we realize with our limited narrow-band sense perception. California State University professor Balaragu's paper on, quote, investigation of the spinal cord as a natural receptor antenna for incident EM wave and possible impact on the central nervous system, unquote, reported his team's research on the effects of electromagnetic radiation on living organisms and systems. They found that the human spinal cord acts as a natural radio antenna, absorbing EMF waves without our knowledge. Now, the spinal cord is a perfect receptor of the phi alpha wave. It grows within the human brain as one integrated system, almost from conception. Images of a 3-month-old fetus show the spinal cord already developed as a thin fibrous filament which enters the brain and merges with the pons and cerebral pedicle as one undifferentiated tissue. As the phi alpha wave is absorbed by the fetal spinal cord, the biophotons become separated from the ion-held phi alpha memories. The biophotons pass through the fetal tissue, leaving the memories behind. These memories are stored within the spinal cord tissue and are gradually uploaded in the cerebral cortex and then into the neural tissue over the neural net of the child over the child's youth. Phi alpha memories are not consciously remembered because they are suppressed by ultra-short-term and working memories. However, meditation and other means of slowing the mind's focus upon superficial stimuli can aid in opening the conscious mind to these older memories. This is the end of part 2 Thank you so much for watching, and good night.